In this video, I want to talk about compute log likelihood. So before we really get into details of it, one most important thing is, first of all, what is this likelihood or log likelihood? So uh, that's very important to just keep in mind, because you will run into this in this assignment and also in the next assignment. So I believe in the lecture slide here, actually, the professor discusses about likelihood functions. So you may want to go and review this part of the video. And here, if you look, so the log likelihood of the model over the data set measures how the model fits the observed data. This measure allows us to compare different model choices quantitatively. So the most important thing that you get out of this likelihood or log likelihood function is that given two models, you're able to make a better decision on how the model fits the observed data, whether this one fits or is it likely that one model fits the data better than the other. For example, in this assignment, whether the realistic model where all the joints are connected with parents, would that model, um, is it more likely that that would fit the data better than the naive Bayes model, for example? So it helps you choose the model. So that's what this likelihood or log likelihood is all about. Okay, coming to the equations. So you are given, so the first equation here is this guy right here, and the other one is this equation. So equation 12 and equation 13. So I tried to break that down. If it is very confusing, just ignore my video, but I think I tried to do whatever I can. So let's see. So in here, if you go back to this description of this assignment, they gave you two hints, actually, two very important hints. So let's try to read them. Use log norm PDF instead of log of norm PDF to prevent underflow. So you have to use this guy. And so that part, I think, is pretty obvious, hopefully, and doesn't really warrant much explanation. However, the second one, that's where things might, it's actually very simple, but it's basically, you're converting into log, and then you're coming back to the normal space by exponentiating it, and then so I'll break it down. So that's this second part right here. Okay. So what I did here is I actually have a Word doc here. I tried to mark these things. So this is our equation 12. This is our equation 13. So if you notice that part right here, that P of in the first equation, that is expanded in this equation number 13. So I tried to combine these two here. So that's what I have here in this part of the this Word document. So this is the combined one. So I basically combined equation 12 and 13 and see if I can explain what these hints and how they are related to this. Okay. So as you can see, in the original equation you have for I equals 1 to n. So that's what that is. I equals 1 to n, which is the number of examples in the data set. Then you have the log. Okay, that's what that is. Now, the way this P of O1, O2, all the way till O10, that's defined by equation 13 right here. So eventually you get this part. All this is standard stuff that you have done in the earlier module. So that part I basically grabbed from here to here, and then basically pasted that here. So that's what that part is. Okay. So if you read this entire combined one, what are we saying here? So for each for each example in the training set, that is I equals 1 to n, then you have the log of. Then we said, okay, for each class, right, whether for the human or alien, right, so that's what you have here, obviously 1 to 2. What do? Then you take probability of that class being probability of C equals K, probability of C equals being, when K is 1, I think I actually have to go and refer what that means. I think one is obviously for alien, the other for the human beings. And then, So as you go through each class, then what do you have to do for each class? Then again you have to loop all the body parts for that, right? So for a base I equals 1 to 10. Okay. Now, if you just take this part from probability of C, obviously, I think here is an I, here is an I, so please don't get confused. Um, anyway, so because I tried to cut from this part, that's why they both have same I equals 1 and I equals 1. But I hope you understand what I'm trying to say here. So basically for each body part, that's what this guy is. Now remember in your hint, they said log of sum of exp of log prob, right? So if you actually look at the hint, they're saying you may use log of sum of exp of log prob to do the addition in original space, comma sum of prob. Okay, what are all these things? Let's try to understand. So this log prob, right? So basically this product that I underlined with this line right here. So you convert this part of products into log space and store it in log prob. So what would be the dimensions of log prob? That's most important. So that so the dimensions of log prob would be k by 1. Okay. This thing that I just highlighted. If you actually go through each of these body parts for each alien or human. So that underlined part right there, that will be your log prob whose dimensions will be k by 1. And then, okay, great, we got that. Then why are we exponentiating it back? Because so if you look in your formula here, so it just says P of O1 comma all the way till O10. So, and there is no log in the formula for this part. So you are trying to exponentiate it back so that you're moving back from log to the normal space. Okay. So that's what this part is. All right. The exponentiation of log prob. Now, what are you summing? Well, remember we said log prob is in which it's in k by 1, right? So you want to sum for all classes that k equals 1 to 2. That's what that sum is. Okay. Then next thing is, okay, obviously you have this log guy here, right? Log of. So you basically take that log. So so I hope you get it at least, this log of sum of exponentiation of log prob. Great. Once you got it, they also said then comma sum of prob. Okay, what is that again? Well, what would be the dimensions of prob? That would be n by 1 because you have n examples, right? So that's what, so you would store for each example, so prob would be n by 1. For each example, you would be doing this entire formula and storing that in prob. And then you basically sum the entire thing. Okay, I hope this gives you a visual picturization of what this is. That's all. I believe really that's all there is to this. If you once you're able to implement this, you will really get it right. Okay, obviously you have to take care of things like when you're actually looping through, right? If there is a parent, or if it is a parent, and if it is not parent, what you have to do. And there are few other things like this is very important because they say that it has to work with both. G can be either 10 by 2 or 10 by 2 by 2, different structure for each class, and so on. So make sure you read this and you implement the code. But I think this is sometimes this part is the confusing one, which is why I try to make this video. Hope it is helpful. But one last thing again I will say, compute log likelihood, please do not lose track of what actually it means, right? So I'll say it one more time. It basically the log likelihood of the model or the data set. So how well does this model fit this data set, right? Would a naive Bayes model fit this data well, or would this realistic model with all edges connected with parents and children, would that fit better? So those kind of decisions, that's what this function will help you make. Good luck and thank you.